Continuing where we left off, we're going to go to section 2, and that's applying Mendel's principles, and this is looking at basic applications such as Punnett squares. When Mendel was doing his crosses with the pea plants, he realized that he could use principles of probability to predict the outcomes of the pea plants. And so what is probability? Probability is the likelihood that a particular event will occur. And so if you flip a coin, the chances of it being heads is 50%, and the chances of being tails is 50%. And so that is the probability of a coin flip. So if you were to flip a coin 2 times, these are your expected outcomes. You could either have 2 heads in a row, 2 tails in a row, a heads or tails and then a head. And so the chances of flipping a coin and getting heads is 50%, and the chances of flipping a coin and getting another heads is 50%. So you have to multiply those chances to get this 25% chance. So you have a 1 in 4 chance of getting 2 heads in a row, a 1 in 4 chance of getting 2 tails in a row. And for this one, why it says 50% chance is because you have a 50% chance of getting a heads and a tails. And so you could either get a heads first and then a tails, or a tails first and then a heads. And so you have a 1/4 chance of getting this outcome, and then a 1/4 chance of getting this outcome. And because the expected outcome is the same, you have a heads and a tails, it's 50%. It's important to note here about this large number of events, because if you only flip this coin 4 times, so you only have 2 outcomes, say you only get 2 heads and 2 tails, well, now you don't have this, you're not going to see the data here to support this 50% chance. And so you need to flip the coin more than just the 4 times. You need to flip it 1,000 times. And when you do that, you'll see the outcomes will really show these expected outcomes. Starting here with the coin flip, you flip the coin once and get heads, and then so you'd flip again and get another heads. And so that will make you 2 heads, and we call that your genotype. And your genotype is your genetic makeup. And so if you're 2 heads or 2 tails, we call that homozygous. And a homozygous organism is one that has 2 identical alleles for one gene. And so if you have 2 of the same alleles, that makes you homozygous. So for heterozygous, you're an organism that has 2 different alleles for the same gene. So if you flip the coin, get heads, and then flip again and get tails, that will make you heterozygous. Same for the tails and heads. And so for this genotypic ratio, it's a 1 to 2 to 1. So you have a 1 chance out of 4 of being 2 heads, and then you have a 2 chance of being a heads and a tails, and then another 1 chance out of 4 of being 2 tails. So knowing how genetics works with dominant and recessive alleles, we can use something called a Punnett square to predict the genetic outcomes of a cross. So how this works is you take one parent and you put them up here. So we'll start here. We have 2 big S's, and put both of them here. And then when the letter looks the same as the lowercase letter looks the same as a capitalized letter, I always put a dash over it to distinguish between the 2. And so you put this parent's alleles over here, and then it's very simple. You take 1 down, and then this one across. So these alleles are coming from the parents. So this parent only has 2 big S's, so it can only donate 1 big S. And this parent only has 2 little S's, so it can only donate 1 little S. And that's where these are coming from. And so remember that these S's are your genotype for this trait. So these alleles show your genotype. And genotype always describes phenotype, and phenotype is the physical characteristics are what you look like. So if you have a big S, so dominant S, you are a round seed. And if you have a lowercase s, you are a wrinkle seed. And so this cross right here is what we did between the parents, and the only outcome is 1 big S and 1 little s. And so because you have that big S, you're still a round seed, and this will show the F1 generation. So you have a 100% chance the F1 generation will look like this. So now you do an F1 self cross, and so that'll just be an F1 generation cross with another F1 generation. And so these gametes are different, So since you have both alleles, one gamete is giving a small s and one is giving a big S. And same for the other cross. So you have one big S, one little s, one big S, one little s. So it shows when you complete this Punnett square, you have 1 in 4 chances of being 2 big S's, and then a 2 in 4 chances of being a big S and a little s, and then one more time, a 1 in 4 chance of being a little s. And so that phenotypic ratio, that 3 to 1, because it's just your phenotype, it doesn't really care about your genotype. And so in this phenotype, you have both big S's, so that makes you round, and then one big S and a little s, and that still makes you round. And so the 3 comes from the fact that 3 of these offspring are going to be round, and only 1 will be 2 small s's, so wrinkled. And so the phenotype ratio is a 3 to 1, but the genotype ratio would still be the 1 to 2 to 1. So you have 1 being 2 s's, 2 big s's, and then 2 being a big S and a small s, and then that last one would be 2 small s's. So with Punnett squares, you're able to also do it with 2 traits, and we call that a dihybrid cross because it's between 2 traits. And so you'll take the parent generation of a homozygous dominant cross with a homozygous recessive plant, and so this will give you the F1 generation. It'll be a heterozygous for both traits. And so then when you want to figure out the F2 ratios, you'll cross it with itself, so this cross right here. And so how to do this, you start with the first letter and you put it here, and then you will bring that over to this Y, and so that'll give you 2 dominant alleles right here. And so then you also take that first letter and you cross it with that last Y, and so that'll be a dominant with a recessive Y. And then you do that for this R too. So a lowercase r with a capital Y. And last one here. Lowercase r with a lowercase y. And so that's what this one is donating in its gametes. And you'll also fill it out for the same right here on this one. Quickly pointing this out, that it should say green, not yellow, so being the recessive for seed color is green. My bad. If you continue to fill out that Punnett square, this is what you will find. And so what this is showing is the law of independent assortment, and it's that genes for different traits can segregate independently during the formation of gametes. So what that means is that this trait for the seed shape and the trait for seed color, they independently assort, and that's what these gametes are showing, that they don't have to go together. So if you're dominant on here, you're not always going to go with this dominant allele, and so you can go with the recessive allele for the seed color. As you continue adding more and more alleles to these Punnett squares, they get exponentially bigger, and so we won't really go more past a dihybrid cross, but it's important to note with these genotypic ratios and phenotypic ratios that to get 4 small recessive alleles, it's a 1 in 16 chance. So you, out of these 16 boxes, you only have a 1 in 16 chance to get all recessive alleles, and that same goes for the dominant. So having all dominant alleles, it's a 1 in 16 chance. With the phenotypic ratio, it's a little bit easier to do, and that's because the dominant is covering up the recessive trait. And so you're going to find more round and yellow seeds because it only takes 1 dominant allele for each of these traits to be round and yellow. And so if you have 1 R, you're automatically round. If you have one big R, you're automatically round. If you have 1 big Y, you're automatically yellow. And so that ratio is going to be a 9 to 3 to 3 to 1. That's it for section 2. And so this is the vocab that I covered. You should be able to have these defined, and if you weren't able to get all these terms, make sure you go back and get them in the lecture. Now starting with section 3, so it's the other patterns of inheritance. So contrary to what most people think, that most genetics doesn't show those simple patterns of Mendelian genetics, and so the majority of genes have more than 2 alleles that make up for the traits. The first of these exceptions is something called incomplete dominance, and what that is when the heterozygous phenotype lies somewhere between the 2 homozygous phenotypes. And so in this cross, you have a heterozygous flower that has red flowers, and so you have the color, and then it's denotated by an R up here for red, and then it's being crossed with a white flower, so you have color denotated with a W for white. And then so when you take that parent cross and you get the F1 generation, you have the red allele still here and the W allele still here. So they're both capitalized and they're both up here by the color because neither have dominance over the other. And if you were to take a red paint and mix it with white paint, you're going to get that pink. And so that's what that means by the phenotype lies somewhere between the 2 homozygous phenotypes. Now you'll take that F1 and do a cross with it, so you'll cross 2 F1s, and so you'll take this pink flower, cross it with another pink flower, and you'll fill out your Punnett square. You'll have your 1C red here and 1C white here, and same for the other side. And then when you fill out the Punnett square, you'll have 2 C's R's, that'll make a red flower, and then a 2CW, that'll make a white flower, and then you'll get the 2CR and the CW, so that will give you 2 pink flowers. And so you'll get a genotypic ratio of a 1 to 2 to 1, but the phenotypic ratio will be the same. It'll be a 1 to 2 to 1 instead of a 3 to 1 like we saw in the simple inheritance. Next we have codominance, and it's when the phenotypes produced by both alleles are clearly expressed. And so in codominance, you have your 2 different alleles. So if you are R, you're red, so you have your H, and then the R, similar to the incomplete dominance, and then you have your H and your W and your white. But what's different here is that both the white and the red are being shown in this cow. So then you'll take that F1 cross that you get here, and you'll cross it with itself, and so you'll have an HR and an HW cross, fill out a Punnett square, and what you'll get is 1/4 of these will be 2 HRs, 1/4 will be 2 HWs, and 1/4 will be an HR and HW. And so you'll get that genotypic ratio of a 1 to 2 to 1, and then a phenotypic ratio of a 1 to 2 to 1. So it's very easy to mix up incomplete dominance and codominance. So it's important to remember that in incomplete dominance, think of paint mixing together, and then in codominance, that these alleles are both sharing time together. So both the red and the white alleles are hanging out in this cow, and then you see a red and white cow. And then in this one, the red and the paint can't hang out, so they mix each other's paint. So most traits have multiple alleles for them. And multiple alleles is a gene with more than 2 alleles. So an example of that is blood type, where we only have 2 copies of each gene. You can either be AB, AO, AA. Well, that shows that you still have the 2 copies of each gene, but there are so many different types of alleles. So the next is polygenic traits, and these traits are controlled by 2 or more genes. And an example of this is skin color. And so say you have a gene that says you'll have dark skin tone, and another gene that says you have dark skin tone, but you have 5 other genes that are telling you you'll have light skin tone. So all 7 of these genes would be interacting to determine what your skin color is. Lastly is multifactorial genes, and these genes are influenced by the environment. So say your genetics are saying you're going to be 7 feet tall, and so you're determined to be 7 feet tall. But if you are malnourished as a kid and you never get your nutrients that you need, you might only end up growing up to be 5 feet tall. And you're based on what your genetics say you should be versus what you are. This environmental factors are influence your genetics. This is the end of section 3, and once again, if you weren't able to get all this vocab that I went over, make sure you go back and are able to define these. That's it for CoNotes video 2. Make sure you like, comment, subscribe, and favorite for updates. I'll see you guys in class.